Today's video will explain the encapsulation metrics of Fidelity. Hello, I'm James Helfrich. The distinguishing characteristic of object-oriented programming is focusing on the nouns, and classes fundamentally represent nouns. They represent things. So the question is, how do you know if your class design has done a good job of representing a thing? The encapsulation metric of Fidelity is designed to measure exactly this thing. So there are several parts to a class diagram. Take a look at this class diagram. The first part is how the client interacts with it. The second is what it represents. And the third is how much the client can know about it. So how the client interacts with it is the public methods. And this is the metric of convenience. What it represents is the attributes, and this is the metric of fidelity. And how much the client knows about it is the access modifiers. And this is the encapsulation metric of abstraction. We're going to focus on fidelity today. Now, fidelity is the suitability of a class in representing a design concern. Now, there are other definitions which are equally valid. Let's go through each one of them. Fidelity is how well does the attributes capture the thing the class is meant to represent. Now, remember, the classes represent things, not verbs. So they're going to be member variables, otherwise known as attributes, rather than functions. The second is, how does the class represent a useful part of the problem domain? So we take a large problem domain, we try to subdivide it into smaller and smaller pieces. We want to make sure this particular piece corresponds to an aspect of the problem domain. Another definition, fidelity is all about the creating nouns which represent meaningful parts of the application. Now, fidelity is the nouns, namely the member variables, and a meaningful part of the application means every attribute must map to something in the problem domain. Are the attributes cohesive? Fidelity is cohesion for attributes. Now remember that cohesion is the modularization metric, which checks whether a given function does one thing and one thing only. Now does is the operative word because cohesion maps to functions and functions represent verbs. Fidelity is all about nouns, and so it's going to map to things. Does placing these variables in a single bucket simplify the program and make it easier for the client to implement the rest of the program? So fidelity is absolutely about the attributes, and grouping these attributes into a class is meant to simplify the problem domain so the program is easier to use. And finally, class is the quality of a class's member variables, otherwise known as attributes. When we design a class, a critical design concern is how well do we represent our member variables, and fidelity helps us understand that. So there's a close analogy to the levels of fidelity and the levels of cohesion. So we'll start with complete fidelity. The states of the class completely match the design concern. And remember, the design concern is a noun. And then we have extraneous fidelity. There are some extra states, but nothing's missing. So our member variables are sufficient to capture the problem domain, but there's extra stuff that we don't need. Partial, there are missing states, but nothing extra. In other words, part of the problem domain is not completely mapped. Usually this results in a lack of functionality. And finally, poor. The class poorly represents the design concerns. Now we have very similar levels of cohesion, but of course, with cohesion, we're talking about verb, what the function does, where with fidelity, we're talking about nouns, what the class represents. We can learn more about fidelity in the fidelity chapter of the software design textbook.